Hey guys, I'm gonna go through this fairly quickly because you have the ability to pause and start and stop whenever you want, and I need to be quick anyway. So, standard equation where the center is 2, 6, so that's your HK, and goes through the point that, remember this is the one where I said write the answer first, so x minus your h value squared plus y minus your k value squared equals the radius squared. So this is your answer, but we got to figure out what goes here. The way we do that is we plug in the x and the y. So it's going to be -3 minus 2 squared plus 3 minus 6 squared equals our radius squared. So -5 squared, that's a positive 25. -3 squared is 9. So our r squared is 25 plus 9, or 34. And that goes right there. And that is your answer. Okay. Find the center and radius of this circle. So it's x minus your h value. So whenever this is a plus, that means your h value is a negative, right? It's opposite of what it looks like. So my h value is going to be a -1. And then when this is a minus, that's a positive 4 that we're subtracting. So opposite of what it looks like would be a center of -1, 4. And then your radius is the square root of that number. So you get a radius of 12 there. Number 3, all of these, if lines appear tangent, we're going to treat them as tangent. And then just assume these aren't necessarily drawn to scale, because a lot of them I just kind of drew on my own. So this is tangent here. This is tangent here. If this is 130, then the rest of the circle, this part, would be 360 minus 130. So if you subtract that, you get 230 degrees for that. And then what we would do is, it's always the angle equals half of the bigger arc. I should have just plugged it all in. 230 minus the smaller arc, right? So the angle, or in this case x, half of 230 minus 130 is 100. So half of 100 means x will be 50. All right, letter B. This one is segments, not angles and arcs anymore. And you do have a tangent one right here. That's the 6, right? So when you have a tangent, then you set it up 6 squared equals, and then it will be 4, right? From the point to the circle is 4. And then from the point to the other side of the circle, the length of that segment is 4 plus x. Okay, so this is 36 equals 16 plus 4x. Take away the 16. You get 20 equals 4x, divide by 4. So x would be 5. Okay. Letter C. This one, the point meets inside the circle. This is segments, not angles and arcs. So what you're doing is, from that point to the circle is a length of 7, and then go the other direction to the circle. That's a length of x from that point of intersection. And then you do, from the point to the circle is a length of 2, and from the point to the other side of the circle is a length of 6. So you would do 7x equals 12, and then divide by 7. So x is 12/7, or if you divide 12 divided by 7, you get 1.7, we'll say, to the nearest 10th. Okay. Letter D here. So the 10 is the whole length of the chord. That's 10 for this length right here. That's a right angle. This would be the center of the circle. So we're trying to find this length, and 7 is a radius. So if I move that radius over to here, it's still a length of 7. Because 10 is the whole length, this is 5. Some of you were using 7 and 10 to do the Pythagorean theorem, and then you were leaving the 10 by itself on the quiz. For this, you're going to set it up with this as your triangle. So it's going to be x squared plus 5 squared equals 7 squared. So you'll go 49 minus 25, or just subtract 5 squared, if you will. So x squared equals 24. And then you'll take the square root of 24 and round that to the nearest tenth. And that will be 4.9. Okay, so that's D. Letter E here, we're dealing with inscribed angles and the arcs. If you look at, this is 140, this is 130, and then we have Y, and that makes a complete circle. So that means that 130 plus 140 plus Y should equal 360. So you're going to go 360 minus 130 minus 140. So in other words, you're taking away 270. So Y comes out to 90. Okay, so that's this arc. And then if the arc is 90, the angle is going to be half of that. So X is going to be half of 90, which is 45. Okay. And then Z, if your arc here is 140, that's the inscribed, or the intercepted arc, excuse me, for this inscribed angle. So Z is just cutting the 140 in half. So Z is going to be 70. Okay, so that's E. Then F is an angle inside with arcs that it intercepts. So when it's angles and arcs and we're on the inside of the circle, we say the angle equals half of the sum. So 95 plus 135. 95 plus 135 is 230. So we're saying half of 230. So X would be 115 degrees. Okay. On to G. Oh, this one moved a little bit. This 100 is supposed to be for this arc right here. So if that's 100, X is just going to be half of that. So half of 100 makes X 50 degrees. Okay. Another one of these perimeter problems here. So if this is 11, okay, be really careful. It's not this, that's 11. It's this, that's 11. They have to meet at a point outside the circle. So this would be 11. That means if this one is 7, then this one is 7. And then that would make this 10 to add up to 17. So then this would be 10. And if that is 10, then this is going to be 9 to add up to 19. And 9 on this side. So your perimeter is going to be 17 plus 19 plus 9 plus 11, or you could just call that 20, plus 11 plus 7. Okay, so that's all your numbers, and then you would just plug that in. So 17 plus 19 plus 9 plus 11 plus 11 plus 7 is 74. And that will be your perimeter. All right, letter I. I would probably start with X here. And if you look, angle X here, sorry, my drawing wasn't perfect there. This would be your intercepted arc for that angle. So what you're going to do is take the 95 and the 86 and add them together. and you get 181. Okay. So if that whole red arc is 181, you're just going to cut that in half. That would make this angle 90.5 degrees. And then keep in mind, opposites are supplementary. So 90.5 plus y should equal 180. So 180 minus 90.5 is going to give you 89.5 for this one. Okay. And then we have to find z. Z is actually pretty easy to find if you just use all of the arc measures, because those four put together should equals 360. So z plus 95 plus 86 plus 98 equals 360. So really you're just going to go 360 minus 98 minus 86 minus 95, and you get z is 81. Okay. The other way you could have done it is you could have taken this angle and doubled it and then subtracted the 98 from that as well. And then J, your X here is the full length of the chord. So if this is a right angle, then this is a right angle. So we're looking at a right triangle. Remember, this is the one where I always called this piece of it Y. So this would be 4 squared plus y squared equals 6 squared. So take away the 4 squared, and you get y squared equals, that's 36 minus 16, so that's 20. And then we're going to take the square root of 20. Excuse me. So that would be y is approximately 4.5. If we round to the nearest tenth, it's 4.4721. We'll just call it 4.5. So if y is 4.5, then we need to double that to make it the length of x. So 4.5 times 2 would be 9.0. Okay. And then last few here, this first one says in a plane, all the points that are 3 units from the point 2, 1. So 2, 1 is right here. Everything 3 units away would be up 3, right 3, down 3, and to the left 3. And that makes a circle. Ooh. Okay, so in a plane, it would look like that. This one says in space, so this is going to be 3-dimensional. All the points that are 2 centimeters from a line. This is going to be a cylinder that never ends. So that one's hard to draw. Call this 2. Do the same distance this way. That was not. But then make it a cylinder. So something, I should have done a dotted line there. Something like that. Okay. And then the last thing, I feel like we've done this one a million times. Apparently I need to pick a different example. All points 3 centimeters from a segment, that is the track. 3 millimeters rather. Wraps around here, 3 millimeters. Remember, in a plane is 2-dimensional, in space is 3-dimensional. Okay. So that's the extent of it. Test on Friday. And that's kind of a little bit of everything we've been doing.